In this tutorial, we're going to give you an overview of the tool database in the software and how to manage your library of tools. The first thing I'm going to do is show you how to access the tool database. Now, to access the tool database, we do actually need an active job. So we need to either open an existing file or create a new one. So I'm just going to go ahead and create a new file. I'm going to take the default settings and I'm going to press OK. There are a few ways that we can access the tool database from within the software. The first option is within the toolpaths option within the menu bar. So if we press on the toolpaths option, you can see two options down. You'll see that there is the tool database option. If you click that, that will bring up the tool database. The other way to access the tool database is from the toolpaths tab. So if we press this arrow here, that will then bring us into the toolpaths tab, and we'll find the option to access the tool database from this icon here to display the tool database. The other option I'll be covering in a short while, and that is to access the tool database from the individual toolpath options themselves. So with the tool database open, we'll just go over to begin with the actual interface of the tool database. On the left hand side you will find the tool list, which has been pre-populated with some default tools both in Imperial and metric units. Underneath the tool list we will find a bunch of options for us, so we can create a new tool, we can copy a new tool, we can delete whatever we have selected from the tool list. We can create a new group, so if we wanted to create a special group for some specialized tools, maybe for woodworking, we could go ahead, create a new group and create the tools within that group. We can also go ahead and import tools, maybe from a previous version of the software, or tools which we may have exported in the past. And then we also can export any of the tool groups as well, either individual tools or the actual groups of tools. Over on the right hand side of the interface is the tool information. Now if we go into one of the tool groups, so if I go into endmills for instance by pressing on the plus icon there, this will open up the endmills group, and you can see we have 4 tools listed underneath endmills. And we can click on any of these and that will then fill the tool information part of the interface with all the relevant parameters. Now we have the choice. We can either work with the default tools which are set by Vectric, or we can go ahead and completely delete the tool groups which we have at the moment and go ahead and start our own from fresh. And you'll find out just how to do that as you watch me go through all the options during this tutorial. Now one of the first options we may want to do is actually create a new tool. Now you'll see at the bottom the first option is to create a new tool, but the easiest way to actually create a new tool is by using the copy method. So let's just go into the bullnose section for instance, and what we're going to do is we're going to create ourselves a 1/2 inch bullnose tool. So the easiest way to do that is to actually just highlight one of the existing tools and press the copy button. You notice that's going to create an exact replica of the tool that we've just copied. As you can see, as I flick between the two, none of the parameters are changing. And then what we do is basically just go through all the tool information and just apply the relevant information for it. So I'd start off with the name. Now this name is going to be the name that's going to be recognizable to me, so I'm going to type in 0.05 there. Then we have the option to specify a different tool type from the drop down. Now as I want it to be a bullnose, I'm going to keep that the same. We then have the option to add some tool notes. So if we have any specific comments regarding the actual tool itself, we can put them in there. And these could be utilized by extracting that information, placing them in the post-processor code so that when we actually go to run the toolpath, if our control software is compatible with tool notes, we can actually flag up those notes upon running that toolpath. This would require, however, editing of the post-processor files for your particular control software itself. So let's move on to the next section, which is specifying the geometry of the tool. Now you can see at the moment we've got a diameter, and in brackets we have the letter D. Now if we go over to the image on the right hand side, you'll see that D is relating to basically the diameter of the tool itself. So here is where I would specify 0.5 for the diameter of the tool. Then we'd go down to the cutting parameters. And these settings are what we would pick up from the manufacturer's specified settings themselves. So here I'm just going to imagine that they would maybe presume that a 1/2 inch bullnose tool would actually be able to pass down vertically into the material safely at 1/4 inch at a time. The step over is specified how much of a movement in the horizontal direction. Let's imagine we're creating a toolpath that we move over once we've completed a complete pass around on that toolpath. So if we were using this tool for finishing toolpaths, for instance, we may want to keep this around the 10% step over mark, as you can see that we have there. Now if I edited this to 8%, you'll notice that the field on the left in inches will also update automatically. So if I type in 8 here, you'll see that the inches will change to 0.04, so 4/100th of an inch. If I change this to 0.05, you'll see that the percentage will go back over to 10%. Now that's a percentage of the actual diameter of the tool. The next set of options in adding a tool is the feeds and speeds. Now again, these would be what would be recommended by the manufacturer of the tool. So the first option is the spindle speed. So what the tool is actually rated at, we could put here, or the actual spindle speed which we actually want to run the tool at for whatever we normally would be cutting. Now this, at the moment we could specify, let's say 12,000 RPM, but this is only relevant if our CNC and control software support the manual override of the actual spindle speed itself. If not, we can just put any arbitrary value in there, as it won't make a difference when it comes to running that on the CNC itself. Now the next option in the list is to specify the feed rate. Now this is the maximum feed rate that the tool will run at. So if we're doing a 3D toolpath, for instance, it may not get up to this maximum speed because it's the Z-axis is constantly going up and down as it's cutting very intricate parts of a 3D model, for instance. But if we're doing standard pocketing or profiling, we should be able to achieve this as a maximum. Now this is going to vary between different materials that we're going to be using, and most manufacturers will actually specify a feed rate and a plunge rate for different types of materials. So it's always definitely worth checking what the manufacturer states on the label for the particular tool that you're adding. So once we have that value, we can find the actual units per second or minute within the actual feed rate drop down here, and I'm just going to use inches per minute here, and I'm just going to type in a value of 100 inches. Then we also have the option to change the plunge rate, which is how fast we're going to plunge the tool vertically into the material before it starts cutting a pass. So I'm just going to specify maybe just a smaller amount of 30 inches per minute there. Then the last option in the tool information is to specify a tool number. Now this is very most important for people that have a CNC machine that has an automatic tool changer on it, as this number is going to correlate to the number position in your automatic tool changer. Or if we don't have one of those, we can actually just specify a tool number, because we may have organized our tools wherever we keep them with a particular tool number as well. So that'll come in handy if we say use this in conjunction once created toolpath with the job setup sheet, which also outputs the actual tool number. So we can use that in conjunction with that as well. And if you'd like to find out more information about the job setup sheet, I will link that in the related videos section of the tutorial browser. Now once we've specified all of our tool information, all we need to do is simply press apply. If we were finished with editing or adding any tools to the tool database, we can simply press OK, and that will then close the tool database for us. Now we're going to stick around in the tool database, so as we've pressed apply, we can carry on going through the tool database itself. Now if we look at the ordering of the tools underneath the ball nose tool group, you'll see it goes from 1/8 of an inch to 1/2 inch to 1/4 of an inch. Now that is not a very logical order, so what we could do is we could simply highlight the actual tool itself and we can drag it to a new position wherever we feel it would be best. So let's imagine we wanted it down the bottom. We would simply drag it there, and now it runs in a logical order, 1/8, 1/4 inch to 1/2 an inch, like so. So let's imagine that we want to create our own tool group. Now what we do is we first of all work out where we want to place the tool group. So let's imagine I want to create my tool group underneath Imperial Tools. All I do is click on Imperial Tools and click on New Group, like so, and that'll then create a new branch underneath Imperial Tools. Now we can either rename it here, where at the moment we can edit the text within that, or we can edit it underneath the tool information. So let's just imagine I want to call this Vectric Tools. All I need to do then is click apply, and that will automatically change that in the tool list for us. Now let's imagine that I also want to move my ball nose tool, which I've just created, into Vectric Tools. All I need to do is, again, just while it's highlighted, just simply drag that all the way up to when it reaches the Vectric Tools, and when that Vectric Tools is highlighted, simply just let go of the left mouse key, and that'll then put that tool within that new tool group. And within our new tool group, we want to create a brand new tool, one that we haven't actually got one copy of as of yet. So all we need to do then is simply go down and click on New, like so. We can then specify the tool type. So from the tool type, I'm actually going to specify a tapered ball nose. Then we can go ahead and edit the tool information. So I'm going to have a tapered ball nose of a 1/16 of an inch. So I'm just going to remove this information and just type in 1/16 like this. Let's type in 4 inch. And then if we wanted to, we could go ahead and add some tool nose. And then we come down to specifying the geometry of the tapered ball nose tool. Now, the diameter isn't actually the diameter that we would think maybe it was like we did previously with the ball nose tool. The actual diameter here, if we look at the letter D on the image to the right, you see that this actually represents the shank width. So here, I'm just going to type in 1/4 of an inch for my diameter shank. Then we have the side angle, so that's how much of an angle it comes down from the shank to the tip. Now that is specified for us at 3 degrees for this particular tool that I'm adding at the moment. And then we have the tip radius. Now we know that the tip of the actual tapered ball nose is 1/16 of an inch, so what we need to actually add is the radius of that diameter. So that is 1/32. Now within the tip radius section, if we don't actually know what the decimal value of 1/32 is, we can simply just type that equation into the field. So if I just type in 1 divided by 32 and then press the equals key on the keyboard, we should then get the decimal value for the tip radius. After this, we can go ahead and actually specify the rest of the tool parameters. So the next options are the cutting parameters. So we have the pass depth, and that's currently at 4/100 of an inch, so I'm not just going to leave that as it is. We have another two options, which are the step over and the clearance pass step over. So the step over, the first option, is going to be what would be used if we were going to be using, say, a finishing toolpath. So I would keep this low at around about 8 to 10%. And then the clearance pass step over is what we would use if we were going to be using this tool to hog out the majority of material before we would then go over it with a finishing pass. And this isn't the type of tool due to the small nature of the tool's tip, so I'm actually just going to leave the clearance pass step over at 8% as well. Then we go down to the feeds and speeds section, and we just fill these in with whatever is appropriate for the tool itself and obviously our CNC machine. So once I've done that, all I need to do is simply press apply, and you'll notice that that has then been appended to our Vectric Tools tool group. Now there are many types of tools which we can use on a CNC which we couldn't add to our database unless we had some way of replicating the geometry of them in the software. And these are your form-like tools, like an OG cutting tool. And to add these to the database, we need a vector which represents the exact shape of that tool. Now, many manufacturers supply a vector representation of these specialized shaped cutting tools, and we're now going to show you how you could add this to the tool database. So to begin with, we're going to go ahead and press OK to accept all of our changes in the tool database and close the tool database. And then what we're going to do is we're going to open up a file which I've imported in a vector which we've had from a manufacturer of a particular OG form tool, and then we're just going to go ahead and add that to the tool database. So I'm just going to go File and Close, and I'm just going to go ahead and open an existing file, and from the Tutorials Files folder underneath the Tool Database Guide files, we're going to open up this tool database example. Click on it and then click on Open, and this will then open up the file which we're going to use for this particular example. Now you'll see in the center of our work area we have a vector which represents the OG form tool which we want to import into our tool database. Now when creating a new tool in this way using vectors, the tool database only expects us to have the right hand side of the tool vector geometry selected. So we are going to need to make some edits to this vector so that we are only left with the right hand side of the cutting shape. So if we go into node editing mode, and we can get to this by going to the edit objects form and selecting this option here, node editing mode, and then what we can do is we can start to edit the existing vector information. So if we just zoom in by rolling the mouse wheel forward into this vector here and we select it, you'll see that we then have all the makeup points of this particular vector. Now we don't actually need this top span, so I'm just going to right click it and delete span, and we don't actually need the left hand side of this vector. So if I go over the midpoint node here and press right click and then press to cut vector, you'll notice that we now have two separate vectors. So all I need to do now is simply select one and delete that side of the span, and then we are all fine to go ahead and then add this to the tool database. But first, before we can go ahead and do that, we should make sure we have the normal selection mode arrow. So we need to exit node editing mode and go back into normal selection mode. We can do this by clicking on this arrow here, and then if we press F on the keyboard, this will zoom to fit, and we can simply click on the actual vector itself to highlight that for us. Then all we need to do with it selected is just enter the tool database. I'm going to go to toolpath and select the tool database like so, and I'm going to add this tool into the Vectric tools tool group. So all we need to do is just make sure that we highlight that tool group and then click on new, and from the tool type just come down to the option that says form tool. You'll notice straight away that that vector geometry has been picked up, and we've also had some information about the tool already pre-filled in for us. So like the diameter, which has been picked up from that vector selection, and also the name of the tool has been added. But we can also change this. I'm just going to change this to OG to inch like so. I'm going to keep the diameter the same as that is what has been picked up. And then I'm just going to specify just some standard information here. Obviously, if we're going to add any tool of our own, we need to make sure that we're getting the settings from the manufacturer themselves. I'm just going to add in just some standard settings here. So I'm just going to put a step over of 10%, spindle speed of 12,000 RPM, feed rate of 100 inches, so inches per minute, like so, and then a plunge rate of 30 inches a minute. Just give this a tool number of 1 for instance, and then all I need to do is click apply, and you'll see that that then has been added to our Vectric tools tool group, like so. And we can go ahead and now just select between those, and you can see that those have been saved. So what I'm going to do now is just demonstrate that new tool that we've created, our OG of 2 inches. So I'm just going to press OK on the tool database. This is going to accept all of the changes and just close it, like so. I'm going to click in the white space to deselect our vector for our tool, and I'm just going to drag from right to left over our box, which is also in our 2D work area, and I'll just highlight that for us. So what we're going to do is we're going to do a profile around this vector. So let's go ahead and go over to the toolpath tab, and what we're going to do is we're just going to create a simple profile toolpath. So from the toolpath operations, just simply select the profile toolpath, and we're going to start the cut at 0, so the top of the material, and we're going to cut down to 3/4 of an inch. Now here is another place where we can actually access the tool database. As I mentioned earlier, you can press the select button and that will bring open the tool database for us to actually select a tool to use with this toolpath. So what I'm going to do is select our form tool that we've just created and press OK. And what we could even do, if we wished, is we could actually edit the options for this particular toolpath. So if you wanted to change the pass depth from 1/4 inch to 1/2 inch maybe, we can go ahead and just change that there. Now obviously we would need to make sure that that was appropriate before we actually did run anything like that. I'm just going to press OK with that, and what I'm going to do is I'm going to choose to machine on the actual vectors, so the tool itself will follow exactly in the center of this line, and that is all we need just to demonstrate this quickly. So I'm just going to call this profile and OG and just press calculate. and that's calculated our toolpath. We're now in the preview toolpath form, and with it selected, all we need to do is press preview selected toolpath, and that'll then go ahead and run that tool around that vector for us. And you see that we've got that nice view in 3D of the exact shape of that tool cutting around that vector, like so. And you'll also see in the toolpath list that we have a little icon representing our form tool that we've created down the bottom here as well. Now, the last thing that I actually want to show you is how to import and export tools from our tool database. So I'm just going to go ahead and press close on the preview toolpath form there. I'm just going to go and bring the tool database back up by clicking on this icon here. And what we can do is we can import or export any of the tool groups. All we need to do is highlight them and click on import or export. So if I want to export, for instance, the Vectric tools, all I need to do is click on export and just give this a name. So I'm just going to call this Vectric underscore tools and press save. And if I go press the export button again, we should see that we have the Vectric underscore tools.tool file, which is all of our tools that we've just selected to output. And now if I actually delete, let's say, our Vectric tools tool group from our tool database, so just highlight it and press delete, it will ask us if we're sure that we want to delete them all. I'm going to just press OK, and you'll see that's now removed them from my Imperial tools. And all I need to do, if I want to import them into Imperial tools, is highlight Imperial tools, click on import, and this will then load up the open dialog box for us. Simply select the tools file which we're going to import, and then press open. You'll notice that that has then imported our Vectric tools back into our tool database. Now, we might find this useful if we've got more than one copy of the software, so we only have to create one set of tools in our tool database, export it, and then import it into our other copy of the software. Or if we have a friend that's using similar tools, you may just want to hand over a file which has got all your speeds and feeds and cutting parameters for your particular tool group. Now, there is one more thing that I'd like to show you, and that is actually where our tool database is stored, as every time that we edit this, it updates a file. Now, if we ever, for any reason, need to reinstall our software, we need to make sure obviously we take a backup of our tool database first. So let's just press OK on that. If we go to File and open Application Data folder, and this will take us into the directory where all of the files are stored. So in here you'll find a folder called Tool Database, and within here you'll find two files. One will be a tools.tool_db. Now this is the current file which is being used and saved anytime that we make edits to the tool database, and this is the one that we would want to back up. Now the one that's got the extension of .vectric on the end is the actual default tool database. Now if we ever wanted to reinstate this, we would best make a copy of this and then just take off the .vectric to the end of that file name, and then we would be reinstated with all the default tools. Now it's important to note that if we did do that and we moved a tool database from another machine over to this computer, we would need to make sure that the software has a restart before the changes take effect. And that is the same if we wanted to reinstate the existing default tool database. And with that concludes this tutorial, so thank you very much for watching.